Alrighty, let's see what we got here. Skip today because obviously hard. Anyways, number of uniques XOR triplets part 1. You're given an integer array nums of length n, where n is the number of permutations, where n is the permutation of the numbers in the range 1 to n. Sure. So just reordering. A XOR triplet is defined as the XOR of 3 elements, nums at I XOR nums at j XOR nums at k, where I is less than j less than k. Okay, so just 3 elements unique within that thing. Return the number of unique XOR triplets from all possible ijk. So one range is 1 to 2. How do you even get triplets here? Oh, less than or equal to is not unique indices. And return the number of unique values. Okay, so you can basically get 1 or 2. So there's 2 unique values. 3, 1, 2. 3, 1, 2. So I guess you could do 1, 1, 1. Okay, there's just a bunch of them, right? There's just a bunch of them. The thing with XOR is A XOR A is going to give you 0. So you never really want to have XOR of 2 of the same things unless you want to. I mean, you can always have XOR 2 of the same things. It's just going to give you 0. So therefore, it's always possible to get like any of the unique values in a 3 element, given 3 indices. You can choose to do the same in one something different, and the result is that something different value. Or I guess 3 of all the same, and the result is the same value. So it should be 1, 2, or 3 as possible from 3, 1, 2. And then, so 3 is going to be 1, no, 3 is 1, 1, 2 is 1, 0. So besides having all of them, okay, so if they have 2 of the same, then it's going to be whatever is the third one. So that gives you 1, 2, or 3. The only other possibility is they're all the same, which again is the same thing as 2 1 and 1 the other, or the result of 3 different ones. So the result of 3 different ones here would be XOR 1 0 and 0 1 would give you a 1 1. 1 1 XOR 1 1 is going to give you 0. So therefore the 4 unique values are 0 1 2 3. Okay, yeah. So I guess the kind of summary logic, or the kind of the recap would be A, B, what's the symbol for XOR? XOR is, I think, caret. I think it's caret, or I guess I misspelled caret as with an E. Okay. AXOR, or yeah, AXOR A is going to give you A, and then A XOR B XOR B will also give you A. So always possible to have any of the values in the range. So if the range is 1, 2, then it's always possible to get 1, 2. If the range is 3, 1, 2, it's going to be it's, yeah, any value in the range is going to be possible. And considering the indices, if all the indices are the same, or two of the indices are the same, then it's going to be, it's going to give you something of that range. So therefore, the only thing that might possibly go out of range would be wait, let me double check this. So you're given permutations of 1 to n. Yeah, something. So only consider possible out of range outcomes from A XOR B XOR C, where A not equal to B not equal to C. Like if indices are 1, 2, 3. Or in this case, indices 0, 1, 2. Okay. Now that being the case, how would I go about doing it? So it's 1 to n. 1 to n. Like I assume I can't just do a nested for loop. Yeah, it's going to be 10 to the 5th. That'd be not even a nested square loop would be okay. I'm trying to think of how, so how to generate something out of range. So I guess 0 is always possible, right? 0 is always possible if the values are, if n is greater than 3, greater than or equal to 3. Because 1, 2, and 3 would generate 0. Okay, let's go ahead and just do 1 through 4. So 4 is going to be 1, 0, 0. I think that probably gets you, so 4 gives you an extra 1 here. These zeros, means that it's not going to really affect the outcome of the other two numbers that are taking XOR. So it could be 1, 1, it could be 1, 0, could be 0, 1. Yeah, it could be 0, 1 if I take XOR 3 and 2. So therefore, there should be 4 should give 4, 5, 6. Can it be 3? Can it be 3? Yeah, 7, because it could be 1, 0, XOR 0, 1 be 3. So it's additional 4, right? 4, 5, 6, 7. So 1 through 4 should be 8. Is that right? You're given an array n where n is a permutation of the numbers in the range. Okay, whatever. I don't think the order matters, right? I don't think the order matters. This should be 8. Yeah. Go and just define n as just the length of the nums. Okay, let's go and just do 5. So 5, I assume it's just going to still be 8 because it doesn't give you another bit to work with. It's just 3 bits still. Yeah, there's no way 5 can give you less than 8 because I don't think it, yeah, it has to be 8 here. And that should be true with everything that is 3 bits. So all the way up to the biggest 3-bit number would be 7. And it should still be 8. So then the question is, like, if you add an extra bit, yeah, it looks to me it's just the number of bits, right? It's just the number of bits. Because 1 and 2 is 1 bit, so you have 2 outcomes. 1, 2, 3 is 2 bits. A little strange, actually. The number 3 is 2 bits, and then the number 4 is 3 bits. So the first bit gives you 2 options. The next bit only gives you 1 extra option. But I think it just ends up being the number of bits is, yeah, the number of bits determines the number of outcomes. Okay. With 2, yeah. The number of bits determines the number of outcomes. How would I find the number of bits here? I think it's log base 2. Oh my god. What is the thing? Log 2. This gives me this gives me a decimal. Log argument base. Bit length. Nums dot bit length minus 1. Interesting. I guess the question is, how fast is math.log compared to bit length? Bit length is 1.5 times faster. Okay. So yeah, I just care about bit length. It's a parameter, the integer is the is what it's called on. I think it should be bit length minus 1. Why the bit length minus 1? Let me just try bit length. Why is this bit length? It must have a leading B or a leading something here, right? Is the minus 1 in bit length due to a leading kind of a letter to denote binary in string? I think it's an X. The negative 1 is pure mathematics. Two decimal of 1 is 1. The bit length is 1. It's 0. Okay. I think that has to be an edge case then, because otherwise the formula doesn't work in that case. I think because the formula would then give, even if it was just 1 as the range, 1 should give, I guess 1 gives 1 outcome, right? Okay. So I think I just return like n bit length minus 1 to the power of 2, or 2 to the power of this. Okay, I'm slightly off. So it should be, then this is going to be giving the first test case wrong. But I think this should give every other test case right. So 8, this should give me 16. Okay, so handling this one. So here, the bit length is 2. Why is this the bit length of 1, 2. I think maybe I need to special handling for this. This should be 2 rather than 4. The bit length of 2 is 210, right? Okay. I think maybe I'll just do special handling here. If the bits is n, the bit length of this, if the bits is equal to, if the bits is 3 is, no, I guess here, I should just do it like this. If n is less than 3, return n, I think. If it's 2, then there's 2. If it's 1, then there's 1. Yeah. All right. I wish I could just enter n rather than the permutation of n. but let's go and just do 2 more, I guess. 9, 10, 11, 13, 14, 15. And then I'll do one with 16. Okay. All right. Sure. So summary is the extra the math, the number of possible outcomes of the XOR of 3 values from 1 to n really depend on the number of bits in n. Basically, any possible value from 1 to n from 1 bit. So any possible value from 1 up to any usage of the bits in n is doable. So if n has, let's say, 10 bits, 1 up to like all ones, 10 ones, to 10 1 is doable, where 10 ones would be like 2 to the 10th, 2 to the 11th minus 1 is all ones. Additionally, edge case of additionally 0 is a possible outcome when n is greater than 2. Like there's no way of actually getting 0 without having three unique values in the range. So just kind of do the appropriate logic for that. So the appropriate logic here is just find length, use bit length to find the number of bits that are unique, and then handle the sub 2 case correctly, or sub 3 case correctly. Time complexity is going to be L1, since all the steps are in general constant speed. Space complexity is L1, since no extra space is needed. Okay.